Alright, everybody. Time for part 2 of the 11.1 and 11.2, or whatever section it is now, notes. The notes on area of polygons. This part of the video, part 2, is going to talk about examples that use the formulas that we just talked about, and how we can use these to help us find areas and things like that. We're going to be calling a few other things back. You might already see where in some places on this sheet. For example, in our first example. So let's just dive right into it. First example, a length of the hypotenuse of a right triangle is 68 centimeters, and one of the legs is 32 centimeters. Find the area. Well, in any problem that involves shapes, it is not a bad idea to start out by drawing a picture that's going to help us. So, picture for this one, we have a right triangle, we're told that, and we know that the hypotenuse of that triangle is 68 centimeters, and we know that one of the legs is 32 centimeters, and we need to find the area of this triangle. Well, remember that the area is 1/2 base times height. And remember that base times height needs to be two perpendicular lines. Well, it just so happens that in this right triangle, we have this 32, and we have this other leg that is perpendicular to it. So we could use those as base and height. But before we can, we need to know what this missing length is. And this is what I'm talking about. We're going to be calling back something here that we have seen before, but we need it again. So we're going to use it. That is Pythagorean theorem. So we'll set it up. A squared, we could say 32 is A, x is B. So we'll have 32 squared plus B squared equals 68 squared. 32 squared is 1024 plus B squared equals, and 68 squared is 4,624. So, a good step would be to subtract 1024 from both sides. That gives us that B squared is 3,600. And now that we know that, all we have to do is take the square root of 3,600. So that B squared becomes B, and we find out that B equals 60. So that's that missing side. And now that we know that side, we can use the area formula to find out what it is. And we'll have 1/2 times the base is 60, and the height is 32. So now we just have to do that. Remember, 1/2 is also 0.5. You could use that. So 1/2 times 60 times 32, and we get 960. Now, the units in the problem were given to us as centimeters. When we're doing area, we're going to need to use centimeters squared. We're squaring because these objects are all two-dimensional. So it's not just length, but it's length times length. It's length squared. Centimeters squared in this problem. If you're not given a unit, you don't have to put a unit down. But if you are given a unit, you should. Brings us to our second example. Find the area of the parallelogram. So, the big thing you got to be careful of in this type of problem is that you use the correct thing, that is the height. Because you'll notice there are two things that kind of look like height. Remember that the height needs to be perpendicular to the base. Now, if we know that it's 10 up here, we can use that as the base. We also could say that we know that since it's 10 up there, and this is a parallelogram, we also have a length of 10 all the way down here. Now, as far as which one of these two numbers, 7.2 or 6, we should use, we want to use the one that is perpendicular to 10. 7.2 is coming into 10 at an angle, so we don't want to use that one. We want to use this one. So our area is base times height, which in this case is 6 times 10. I kind of swapped them, but it doesn't really matter in multiplication, which equals 60. So that's that one. That's all you have to know for that one. Now in this one, number 3, find the area of a trapezoid. This problem is going to be pretty straightforward. Here's our base 1, here's our base 2, here's our height, and we just have to plug them into our formula, which was 1/2 base 1 plus base 2 times height. So that's going to give us 1/2 in this problem, 7.6 plus 4.8 times 5. You may want to use your calculator on this one. And you'll just basically, what I would recommend doing is I would recommend entering in the 7.6 plus 4.8 first, figure out what that is, multiply that by 0.5, which is the 1/2, and then multiply that by the height. And you should get 31 as the area. Last 2 problems. So, we know that a rhombus, again, I'm drawing a picture. We're told that a rhombus has side lengths that are 5, and we know that one of the diagonals has a length of 6. And we need to find the area. So if we know that this is 6, I'm going to draw the other diagonal in. We know that this is 3 and 3. An important property to remember for rhombi at this point is that we have perpendicular lines happening where the diagonals meet, which means we have right angles, which means we can use Pythagorean theorem to help us find the length of the missing diagonal. If we want to find half of that diagonal's length, we can do 3 squared plus x squared equals 5 squared. 9 plus x squared equals 25. Subtract 9 from both sides, and we get x squared equals 16. Square root of both of those gives us that x equals 4. And if half of it is 4, then that whole diagonal has a length of 8. So then we know both diagonals' lengths, and we can use the area formula for a rhombus. 1/2 times d1 times d2, which means that we'll have 1/2 times 6 times 8. 6 times 8 is 48, and half of 48 is 24. And we do have units in this problem, which are feet, so it's going to be 24 feet squared. Lastly, find the area of this kite. So in a kite, remember, one of the diagonals is not going to be split evenly. You can see that already given to us here. We know that the entire length of this diagonal is 9. But one thing that is also true is that one of the diagonals is split down the middle. So if we know that this side is 2, this side will also be 2, giving the total length of this diagonal as 4. And now we just use the same area formula that we did for a rhombus, because they are the same, at least the same area formula. So area equals 1/2 times d1 times d2, which in this case is 1/2 times 4 times 9. 4 times 9 is 36, and 1/2 of 36 is 18. And there is no unit here to speak of, so 18 can be our final answer. So, in general, you can see how these area formulas are working. We're using a little bit of Pythagorean theorem here in some of the problems, but not in all of them. And you've got to understand Pythagorean theorem is being used because we have a lot of perpendicular lines popping up, because base and height are always related by perpendicular lines, and these diagonals are perpendicular to each other when we're dealing with a rhombus and a kite. So you're going to see a lot of that at times when you're trying to solve this type of problem. That's going to pop up again and again. So just don't be discouraged by it. Just roll with it and remember some of your older math. That is it for this video. That's it for these first 2 sections. We are going to be moving on next to circles and a little bit about area of circles and that kind of thing. So you'll see when we get there, which is coming up in the next video. See you at that time.